Good afternoon, everyone. We're going to switch gears from the previous talk, and we're actually going to talk about something that's usually not discussed that much at SIGGRAPH. We're going to look about problems of racial bias. So this has been getting some increased attention over the last few years, especially after the murder of George Floyd in 2020. And remember all the worldwide protests that followed, including right here in Vancouver, which involved thousands of people. So to my knowledge, this is the first year that these issues have appeared in the technical program of SIGGRAPH, and I believe that this is actually the first in-person technical talk that had openly discussed it. All right, so let's get right to it. Computer graphics research has a race problem. Probably heard the term systemic racism, and in the computer graphics research community, we are not exempt from it. So racism is baked into our everyday institutions, whether we like it or not. And if we don't try to deal with it directly, then we're just going to end up reproducing all of the same existing inequalities from history. We've actually already done this. So this is already happening in computer graphics. So if you look at old classic manuals on movie lighting, like this one, John Alton's Painting with Light, when he talks about lighting a human face, he's almost exclusively talking about lighting a white face. So of course he did. These are the faces he was talking about. This is pre-civil rights America, right? This is an era when it would have been like really dicey for me to try to use the same bathroom as a white person. Things were different back then. So of course that's what he meant when he wrote this book. But if we fast forward to today, when we're talking about rendering a human face, we're actually still talking in the same way about the exact same thing. So you can do a sampling of rendering papers, especially some of the foundational papers on this topic, like Jensen et al. 2001, and you can see the language is exactly the same. So it says, let's render a human face. And by human face, we're going to show exclusively white faces. So here's a bunch of rendering papers over the last 20 years that purport to be rendering human faces or human skin, or most insidiously just skin. And they only show white faces. So if you look at these papers, it's not like I cherry-picked just the picture of the white person in it. There's no black or brown people in any of these papers. So just like John Alton meant in the 1940s, when we say human face in computer graphics, we mean white face. Again, in graphics, when we talk about skin, we're talking about white skin. And we've actually codified the light transport phenomena that's most important to white skin, subsurface scattering, and we've turned that into a synonym for skin. Now something very disturbing then happens. So unfortunately, once you cast things as a double integral like this, it essentially becomes impossible for anybody but a very small number of non-specialists to dispute. So the racial assumption, it then becomes embedded in the math. So if we look at the faces of some black people, though, we can see that it's actually not the ethereal glow of subsurface scattering that dominates the appearance. It's the really intricate and expressive specular highlights that dominate. So subsurface scattering does not characterize all skin, but we live in a world that is freighted with the legacy of systemic racism, and as a result, this is what our formulations look like. So there are papers that do try to diversify, but unfortunately, they're in the vast minority, and they're hobbled from the start from the fact that they have to start from mathematical models that are custom made for white skin. So where's the customized GGX or Burley distribution that captures all of the great highlights on Delroy Lindo's face, the actor from the slide before? There is none. So we haven't done this research. This is systemic racism in action. So I'm only picking on rendering folks here because it's the easiest to cram into the talk slot that I've been allocated. But actually, this sort of thing has happened in other places in computer graphics as well. So when we talk about hair, we explicitly avoid talking about this kind of hair. So professional stylists call this type 4 hair. This is also called afro-textured hair or kinky hair. And once again, this type of hair, it doesn't show up in graphics. You look at the papers on hair over the last 20 years, and it's all straight hair or wavy hair. So again, these problems are systemic. This is history that all predates us, and it goes back to the analog era, but we have recapitulated all those biases into the modern day. So again, we look at the hair that John Alton was lighting, and this is what counted as human hair back in the 1940s. And again, we've just carried that bias forward into the present day. So I actually gave a talk on this last year at the DEI Summit at SIGGRAPH. So this topic has appeared at SIGGRAPH. This is the first time that we've actually discussed it in the technical program, though, not just in the DEI Summit. And that talk from last year, it's actually on YouTube. So here's a QR code for it if you want to go watch that one instead. It's actually what I've just given is a 5-minute summary of that talk. There's actually lots more detail on all the stuff that I just talked about. And if you want to see all those details, you can go watch the talk here. Today, though, I want to talk about something a little bit different. All right, let's start with a seemingly basic question. So, how do we measure human features in computer graphics? To start with, how do we measure human skin? So we can take a closer look at some of the good faith efforts that graphics researchers have put into trying to capture that span between white and black skin. So one of the largest scale studies done in computer graphics on skin diversity is this one from 2006, Wyrick et al. This is actually the paper that I showed you a minute ago that showed the brown face and the white face. So they use something called the Fitzpatrick system to characterize skin color. So you can see the types in the column on the left, the Roman numerals, and you can see the colors that they're supposed to correspond to in the second column. So other papers, they've tried to use this scale as well. Here's one from Donner 2008. And if we look into that paper, here it is, right? They use the Fitzpatrick skin typing system as well. Here's Iglesias 2015. This is Diego Gutierrez's group over in Zaragoza. So it's not just US authors that use this. And again, we see it again, Fitzpatrick system. So there's more, but I hope you get the point. There's a bunch of people in graphics that use this thing called the Fitzpatrick scale. What is the Fitzpatrick scale? All right, so it actually goes back to Thomas Fitzpatrick. He was a Harvard dermatologist. He proposed this skin typing system back in the 1970s. This is actually a paper of his from the 80s. This is actually the one that gets cited the most. All right, if we start looking at this paper, it's really weird. All right, so here is a figure from one of the from that paper from the 1980s, and if we start looking at the labels on it, what is he talking about? All right, on the left, he's talking about sun exposure for some reason. Right in the middle, he's talking about 3 MEDs, sun exposure. This is how much do you burn after 3 hours in the midday sun? And then on the right here, this is how much are you tanned after a week? So the Fitzpatrick system is actually based on a questionnaire. He's actually asking people, how much do you burn after 3 hours in the sun? And how much are you tanned after a week, after 3 hours in the sun? This is really weird, right? So I thought that we were measuring the color of people's skin, right? So why are we talking about the speed at which you burn under the noonday sun? Why are we using a proxy for melanin in this way? Why are we not actually doing a direct measurement? Okay, if you have these questions, then actually Fitzpatrick had these exact same questions as well. So if you go back to his paper that gets cited a lot, at the end of the paper, he actually complains about people using it for this. So he says, what is needed for an objective method of sun-reactive skin typing is a quantitative means of measuring the degree of tanning response. So he's talking about what his paper doesn't do, saying it's just a questionnaire. It's not a scientific measurement. Stop treating it like it's some sort of lab measurement. So what is going on? How come Fitzpatrick himself, he was bagging on his own scale, even in his own lifetime? And yet, decades later, we in computer graphics, we seem to be using it. And the thing is, it's not just in computer graphics. If you look at computer vision, if you look at medical physics, they all use the Fitzpatrick scale. It's everywhere. Why is that? Okay, I'm going to propose something a little bit different. All right, this will look a little bit better than the Fitzpatrick scale, I hope. It'll be a little bit more scientific. All right, so why don't we have a palette of colors? All right, so we're going to hand everyone a palette of colors. If you want to classify someone's skin color, we're going to just hold this palette up against their skin, and from that, you're going to read off a number. All right. So people have actually done this in the past. I'm not just making this up out of thin air. This isn't perfect. We're still not using some sort of calibrated sensor of some kind, but at least this is more direct of a measurement than asking people a questionnaire about how tan they get under the noonday sun, right? So as I said, this is not something I made up myself. This is something called the von Luschen scale. This was a really popular system back in the 1950s. So this seems a little bit more calibrated than the Fitzpatrick scale. Why isn't this used anymore? Right. So things get pretty ugly now. Those images, the von Luschen scale, I got them off of the US Holocaust Museum website. So this was actually the scale that was used by the Nazis during World War II to sort people into the master race and into inferior races. This was a scale that was used for genocide. Now, I want to be fair to Felix von Luschen himself. He passed away in the 1920s before all of that happened. It is not clear that he ever intended his work to be used in this way. But during World War II, that is what his scale was used for. I'm speculating lightly here, but it's not that hard to see. After World War II, when the full scale of the Nazi eugenics program became clear, nobody wanted to use this system anymore. Nobody wants to use the tool that had already been used for genocide. So when this other thing came along, this Fitzpatrick scale from dermatology, it was something else, anything else that is not associated with Nazis, and people just started using that one instead. It's not hard to imagine, right? I want to emphasize again that I am lightly speculating. There actually is probably lots of scholarship and books written on this topic, but to be honest, when I hit this point in my historical digging to prepare for this talk, I had to stop. All right, this stuff was getting really painful to look at. This is not what I signed up for when I came to SIGGRAPH. This is not what some of you probably signed up for when you decided to come to this talk, right? Why are we talking about the Holocaust? This is supposed to be a computer graphics conference. Okay, in computer graphics, though, this is how we measure human skin. It's a weird tanning-based scale that people glommed onto because they were trying to back away from the Nazis. All right, so let's run it again. Let's look at human hair. All right, so in graphics, how do we classify human hair? There's not actually as much on this, and I promise you there's no Nazis involved. Okay, so what we saw before was that when we say hair in computer graphics, we actually mean straight hair. So the most popular hair typing system out there for like hairstylists is called the Walker system. All right, who is Walker? This is Walker, Andre Walker. He developed this system back in the 1990s because he had his own line of hair care products and he wanted a system for people to be able to choose between the different products. And this is actually his main claim to fame. So he was Oprah Winfrey's hairstylist for years and years. And you can see him here working with his favorite client. So no Nazis, just Oprah. In fact, it's a great story, right? It's a hairstylist. Her hairstylist became a successful entrepreneur. That's great. That's great. Okay, we've now seen three separate scales for measuring human features: Fitzpatrick, von Luschen, and Walker. There's actually a pattern here. So type 1 is always the white European feature. So here we see it on the Fitzpatrick scale. Pale skin, type 1. All right, von Luschen scale, pale skin, type 1. Walker scale, straight hair, type 1. The black feature, like dark skin, kinky hair, that's always some big number. It's not even a consistent big number. All right, so Fitzpatrick scale, black skin, type 6. Von Luschen scale, black skin, type 36. And Walker, type 4. All right, there's actually more systems for measuring human features out there. L'Oreal has a system for hair classification. It has the exact same feature though. So here you see it along the bottom: straight hair type 1, kinky hair type 8. All right, and actually Google just released a type system back in May called the Monk system, and unfortunately, it's the same exact problem actually. Uh, White skin on Monk is 1, and black skin on Monk is 10. All right, so all these systems, they give the European feature a special status. In all cases, whiteness is number 1. All right, literally. Literally, whiteness is number one. This is white supremacy. So this is not idle wordplay. I'm directly referencing the fact that the Nazis used a system that put them at number one in order to establish the master race back during World War II. It's white supremacy. So again, we're coming back to the basic question of how we measure human features in computer graphics. Why does the hegemonic feature always gravitate towards one? Well, we can think about this from a lot of different directions, but let's try to think about it quantitatively. So one does have a very special meaning, right? So it's a multiplicative identity. So multiply it by a number, you get the same number back. No other number but one has this multiplicative property. So for that reason, we literally call it the identity, right? It has a very special position within the number system. It's the identity. Now, if you work in computer graphics, you do this a billion times a day, right? Normalize a vector. What is that? All right, we peg its magnitude to one. Once you do this, all sorts of special stuff happens, right? Literally, this is considered normal. It's the baseline. It has a very special status in our minds. So it's the identity, it's what's normal. So what effect does pegging all of these features to one have in our research? How does it influence our research priorities? So just on a day-to-day development perspective, if your code doesn't work for the identity case, it's broken, right? You have nothing. If it doesn't work on unit vectors, if it doesn't work on the unit on an identity matrix, it's broken, right? You have nothing. So what do we do on the day-to-day? We make extra sure that the identity case is fully debugged before we move on to anything else, right? That's just how research practice works, right? And I think that this is exactly what we've done, just spanning decades. So let's get the identity case working. Let's get the identity case working. The thing is, we've already seen it. There's actually no technical reason that these features should be the identity case. So these features don't have some sort of special status. There's actually no reason to believe that getting this case right is some sort of technical precondition for getting other features right. So what do we do now? I'm going to pose a question to you, the audience. Can you think of a better measurement system? There's actually a pretty clean problem statement here. So can you devise a measurement system that lacks idempotence? So no number has a special status like one. No measurement can then have a special status. Now, the answer here, it might be no. So maybe some of you number theorists out there say, oh, that's not possible. You can't have a number system like that. That's number systems 101. I'm not a number theorist, so that would be an unfortunate answer, but at least it would be an answer. Or maybe there is an answer. Maybe there is a clean solution. If you can think of one, I'm serious. You should submit it as a talk to SIGGRAPH next year. I would love to see it. Really, you should submit it. Now, there's a broader question here. Can math even fix this? We should consider that the answer here, it actually might be no. So it might be that somebody comes up with a beautiful new system, but whatever value gets assigned to white skin, it eventually just sort of gravitates toward this shorthand for good. So my colleague Wojciech Jaros, one of the co-authors of this paper, he did point this out. So we see this happen with arbitrary number systems all the time. So if you went to college in the US, when you say stuff like, I have a 4.0 or I got a 1600, we all know what that means, right? So there are numbers that have this halo of good around them, even though they're not one. So it may be that we come up with some different way of measuring things, and that can also just get systematically distorted. This might happen, or it might not. Again, if you out in the audience, if you have an idea for this, I think it's worth a try, because what we're doing right now, it's not working. So the good news here is that if you think it's important to combat these issues, you're not alone. I said that this is the first year that these issues are being discussed at SIGGRAPH, but they're being discussed very widely. There are 6 other events at SIGGRAPH this year that discuss bias on the technical level. So it's not just me that cares about this. There are lots of other people in the community that care about this too. So there will be a few other chances to talk about these and related issues this year. One of the related issues is gender representation in research practices. Are our research practices being trans exclusionary? We're actually going to have an in-person roundtable on this on Wednesday in East Building rooms 1 and 3. The other is that it will be discussed out of a birds of a feather on Zoom actually in 2 hours. All right. So here's the name of the BOF, the birds of a feather. Here's a QR code for where it is on Hub. I'll post this to the Discord channel as well. And with that, thanks for your attention. I'd be happy to take your questions now.